guys, Mr. Mackie here. Now yesterday I was looking at converting between different weights and mass, and I wanted you to find for me how much I lost since the lockdown and how much my new weight is in kilograms, pounds and ounces. So firstly, let's find out how much I lost since the lockdown. And because I went from 15.9 to 14.2, I lost 1.7 stone. So if 1 stone's 6.35, we times that 6.35 by 1.7. So the number of kilograms that I lost will total 10.80. That's to 2 decimal places. Now to find out how many pounds I lost, you have to divide the 10.8 by 0.45. Because 1 pound is that, so you need to do some division. And that will get you 24. And then how many ounces will you divide 10.8 by 0.03, and you will get 360. So since this lockdown, I have lost 1.7 stone, which is the equivalent of 10.8 kilograms, 24 pounds, or 360 ounces. Now, how much is my new weight in terms of these measurements? This one will be slightly easier because we know what the stone is already. So we do 14.2 times 6.35, and that will get us 90.17. Now, we divide 90.17 by 0.45, and that will get us 200.38. And we divide 90.17 by 0.03 to find the final one, which is 3005.67. So my new weight are these. Probably need to lose a bit more, but I'm still happy with what I've achieved. Now, we're still going to focus on converting today, but we're not going to be doing converting between weights, liquid and distance. We're going to be looking at another type of conversion between fractions, decimals and percentages. Let's see. Now today we're going to be focusing on converting fractions into decimals. Now, most people who are watching this video will know by now that 1/2 is as a decimal 0.5. But there will be some people out there who go, no, it's not, no idea what you're talking about. So what we're going to do is I'm going to prove to you that it's this, call it your party trick. So what we do is we imagine that we're just dividing, because that's what fractions are at the end of the day. We're dividing. So we're going to be dividing 1 by 2. Now I've drawn it as a bus stop method because, you know, that's how I've always done division. How many 2's go into 1? Well, 0. Now we put our decimal place here and we carry on with a few zeros there and we line up our decimals here. And now we turn that into 10 because we're carrying the remainder across. How many 2's go into 10? Well, 5. Is there a remainder? No, so we stop there. And that's how you prove it. And what we've also done is I've now shown you the method on how to turn fractions into decimals. You just divide. You divide the numerator, the top number, by the denominator, the bottom number, and you will end up with a decimal, which is the conversion. How cool's that? Let's do another one. Now let's turn 5 into 8, 5 over 8 into a decimal. Now I've already made it a bit easier by putting the decimal places in the point here, just because I know we're making decimal, might as well go one step ahead. Now, how many 8's go into 5? 0. Put our decimal point here, we make the remainder. How many 8's go into 50? The remainder from this, well, we do the 8 times table. 8, 16, 24, 32, 40, 48, 56. Stop, too high, so it's 6, with a remainder of 2. How many 8's go into 20? We do our 8 times table. 8, 16, 24. Stop. We've gone too far, so we only go in it twice, with a remainder of 4. How many 8s go into 40? 8, 16, 24, 32, 40. Bang on. It goes in 5 times. There isn't a remainder, so we don't carry on from there. So, 5 over 8 as a converted decimal, 0.625. Brilliant. Now this will lead to a much more special type of decimal. Let's see what I mean. So, 2 over 3. How many 3s go into 2? Well, 0. Decimal points, and we carry the 2 across. How many 3s go into 20? Well, 3, 6, 9, 12, 15, 18, 21. Stop. 18 is the highest, so it goes in 6 times with a remainder of 2. How many 3s go into 20? Well, 6 again, remainder of 2, 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 6 again. Now I would carry on doing this, but I know, because it's been the same every time, that this will always go like this. It will always go the remainder of 2, 6 again, remainder of 2, 6 again. It will never stop. This is a very special type of decimal. This is known as a recurring decimal. This means that the decimal will always carry on in the same pattern and never stop. I mean, the one we just did, the 5 over 8, that is a decimal that is non-recurring because it ended after the 5. This will always carry on. So how do we write it? Well, the way I write it is we do 0.6 with a little dot on the top. That dot tells us that the 6 is the decimal that will be recurring throughout this point. So, because the 6 will be appearing every time, it's no point us writing 0.666 recurring, because it's just that 6 that's going to be recurring all the time. That's what it's telling us. It's telling us that it's 0.6, but the 6 is recurring. So, 2 over 3, or 2/3, converted into a decimal, is 0.6 recurring. Now here's the final one before your challenge. 1 over 7, let's do it. How many 7s go into 1? Well, 0, put the decimal point, remainder of 1. How many 7s go into 10? Well, 7, 14, stop too far, only goes in once, with a remainder of 3. How many 7s go into 30? 7, 14, 21, 28, 35. Stop. 28 was the best, so it goes in 4 times with a remainder of 2. How many 7s go into 20? Well, 7, 14, 21. Stop. It only goes in twice, with a remainder of 6. How many 7s go into 6? Well, 7, 14, 21, 28, 35, 42, 49, 56, 63. Stop. 8 was the highest, with a remainder of 4. How many 7s go into 40? 7, 14, 21, 28, 35, 42. Stop. 5 is the highest, with a remainder of 5. How many 7s go into 50? Well, 7, 14, I'm getting for the tiredness, 21, 28, 35, 42, 49, 56. Stop. 7 was the highest. I'm just going to carry this on a little bit more. You'll know why in a minute. I know it's going on and it's not recurring for now, but I just want to show you something, and that gives us a remainder of 1. How many 7s go into 10? 1, with a remainder of 3. How many 7s go into 30? 4, with a remainder of 2. And so on. Have you noticed it yet? Yes, it is actually a recurring decimal, because it goes 0.142857, 1.2857, 1.142857. It will continuously go on as that. So the question is, how do we write it in a typical calculator? How do we write it? Well, usually the best way to do it is 0.14287, and I put the recurring decimals here and here. The reason why is because this is in between what is going to be recurring throughout the problem. So, 1 over 7 in a decimal form is 0.142857, and all of this is recurring. So, here is your challenge. I have 3 decimals and 4 fractions. I want you to match the decimals to the fractions they converted into. One of these fractions does not match with one of these decimals. So simply, which fraction is the odd one out? Good luck with this. We're going to do more convertings of fractions, decimals and percentages for the rest of this week. But take care on this. Good luck, and I'll see you tomorrow, guys.